generations, it was believed that Earth was at the center of everything. Now, of course, we know that it's not, and that our planet is but a tiny speck in the cosmos. So we have to ask, why don't we see signs of other life out there? There are an extraordinary number of planets in the universe. According to most estimates, planets should be more abundant in space than stars, which is saying something seeing as it's thought that there are upwards of a septillion stars in just the observable universe, just the parts we can see. As we stand then, we haven't yet managed to study even close to 1% of all the planets theorized to exist, simply because we're too far away from most of them. But we have extensively studied those in our own solar system and some more beyond, and although some planets might have possibly harbored life at some other time in their past, we can't say for certain that any do now. Many scientists do of course suspect that there is life on other planets, and probably on one or more of the 2 to 10 billion Earth-like worlds calculated to exist in our galaxy alone. But others argue that the circumstances which led to life on Earth are so spectacularly unlikely that it really could be unique. Whatever your view on it, Earth is the only planet we know of that supports life. But why exactly is that? The oldest fossils we've found date back to around 3.5 billion years ago. We don't have a definitive answer as to how life originally came to be here, but we do have a few theories. One idea, known as panspermia, suggests that life didn't actually start on Earth at all, but arrived here on an asteroid from another planet. That could be the case, but the panspermia theory still doesn't answer how life in general began. One of the most popular theories on that is the idea of a primordial soup, or that life formed in a specific circumstantial solution of materials which eventually became rich in organic compounds. Life came about because these building block compounds just so happened to form at the right place at the right time. It was originally said that these ultra-early chemical reactions were energized by UV rays from the sun. Then, in the 1950s, studies including the Miller-Urey experiment moved scientific thought more toward the idea that the soup would have had to have experienced an early universe version of something like a lightning strike, that it was in some way electrified. More recently, in the late 20th and early 21st centuries, some have called for the traditional soup theory to be discarded altogether, arguing instead that life most likely started deep in the sea near hydrothermal vents, that it was the vents which provided the energy it needed to form. Most models now have it that life did emerge out of the oceans and onto land, but there is still debate over how it occurred in our waters in the first place. What we do have a firmer grasp on is how the conditions on Earth sustain life as we know it. It isn't just one feature of Earth that makes it the only planet with life. There are dozens of small but vital aspects which come together to create the habitable world we know. Among these are Earth's magnetic field, its atmosphere, the water cycle, and its size. Even the conditions outside of Earth itself seem to aid our existence. Jupiter, for example, acts as something like a bodyguard to Earth. It's positioned at just the right location in the solar system so that its massive gravitational pull attracts most of the wayward asteroids that might have otherwise struck our planet. Our own moon, too, is a key player in our planet's habitability, with its gravity helping to stabilize Earth's rotation, which helps to keep the climate steady and the conditions reliable. But there are some aspects of Earth that are so important that scientists specifically look for evidence of them when investigating life on other planets. Water is considered the most vital ingredient for life, and it's almost always the first thing we search for when considering other worlds. Today, Mars has water ice. It's thought it could have liquid water below the surface, and it's likely that the red planet had lots of water in the past. But the only other objects in the solar system we can say with any confidence have water are various moons, like Jupiter's Europa and Saturn's Enceladus. For this reason, these moons are among the top contenders for harboring alien life. So why is water so essential? Well, it's important for a few reasons. Water basically acts as a lubricant to facilitate all the complex molecular chemistry that occurs on Earth. It's also considered a universal solvent, and crucially, liquid water can transport nutrients from one place to another as well as acting as a cleaning fluid. It's key to enabling most essential processes to happen, so it makes quite a lot of sense that the human body should be 60% water. In humans specifically, water regulates body temperature, facilitates digestion, protects the brain and spinal cord, helps to distribute oxygen, and the list goes on. Because of its versatility and uniqueness, it's no wonder that NASA has the strategy to follow the water when searching for life. It's why determining a given planet's climate is also so crucial, to see whether that planet experiences the right range of temperatures for liquid water to exist. The easiest way to do this is to see if the planet you're studying is in the habitable zone around its host star. Earth happens to be positioned inside this range of distances out from our Sun, which allows it to sustain water. If our Sun were a different type of star, however, that range would change and Earth would be a totally different, most likely totally inhospitable place. Just being in the habitable zone isn't enough though. By some accounts, both Venus and Mars are in the confines of the habitable zone at certain points in their orbits, but only one planet out of 3 actually has life. We also have to take into consideration a planet's immediate atmosphere to see what types of gases it's made out of. Venus, for example, is just on the inner edge of the habitable zone and has some of the right conditions to maintain liquid water on its surface, but not all. Not by a long shot. And that's because the Venusian atmosphere is mainly carbon dioxide, meaning that thanks to the greenhouse effect, the average temperature skyrockets to about 462 degrees Celsius, at which point water can only exist as a gas. By comparison, Earth happens to be the right distance from the Sun, and it has a favorable atmospheric composition to sustain liquid water. It's capable of hosting life, while Venus really isn't. There's one final thing though that most other planets don't do, or don't do as well as Earth does. Recycle. Earth is able to recycle and reuse its resources naturally and in various ways. The water cycle allows water to be naturally cleansed, and the carbon cycle allows carbon, life's primary building block, to be scattered around the surface. The acceleration of the greenhouse effect caused by man-made pollution is one thing, but Earth's own carbon-churning processes are integral to how it works. Much of what makes Earth tick rests on tectonic plates. The movement of whole sections of the Earth's crust helps to shift and release stored carbon dioxide back into the atmosphere, but it also moves, redistributes, and facilitates other chemical processes all over the planet. At the highest level, it creates and destroys land. It ensures that our planet's surface is always under development. Nothing on Earth is left to stagnate, and everything is part of one giant moving machine. Scientists think then that tectonic plates are the major reason why Earth boasts such a vibrant and diverse terrain, from barren deserts to vast oceans to dense jungles. And therefore, plate tectonics could be the reason that life has been able to survive for as long as it has, long enough for intelligent life to form. There's strength and resilience in the variety of life, and that variety has come about because Earth itself is constantly changing. The challenging part about drawing conclusions from Earth is that, in the grand scheme of space, life on our planet is just one piece of data. And it's the only piece of positive data we have so far. By studying the diversity of life as we know it, we can better gauge its possibilities and constraints, but only from our perspective on Earth. Perhaps life elsewhere constitutes something that's actually incomprehensible to us in our form. It could be rare, it could be abundant. We could be right on the cusp of discovering it, we might never discover it. It could still truly just not exist at all.
So what's your verdict? Taking into account the various philosophical approaches, the many religious doctrines, the growing scientific understanding, and the far-out alternate theories, including the potential guiding hand of an alien presence, why are we here? What's the reason for all of this stuff? This universe, this world, and this life? Clearly, in searching for the answer, there's a lot to think about.